going to take you through exponential equations. Remember, the word equations, it means you are expecting to deal with something that has an equal sign. What do we do when we have a math problem that has an equal sign? We do know very well that we need to solve. What are we solving? We always solve for the unknown, which is represented by the letter, and that letter could be any letter from A up to Z. Doesn't matter whether it's a capital letter or a small letter. What we know is that our final answer should be letter equals a number. That's how you know you are dealing with an equation. Your final answer will be a letter, it's equals to a number. That letter could be A up to Z. So again, the word exponential, it should just remind you that you might expect that letter to be in the position of the exponent. Remember, a power, it is structured in this format where you have the base and then you have an exponent. This is called a power. So this is where you are now going to be having your A up to Z. So just be aware of that. Maybe let's start with our first problem, and then you will have an idea of what I'm talking about as we continue. So the first problem, let's say we are having 2 to the exponent of x, again raised to a power of 2, and this is equated to 32. Every time when you are given a math problem and you do not know where to start, always look for where you are having the brackets. That will be your starting point. Why the brackets? Because BODMA starts with a letter B. That B stands for brackets. So you look at this structure where you are having the brackets, and you remember that law which says you multiply their exponents. Then you end up having 2 to the exponent 2x, because 2 multiplying by x is 2x, and this is equals to 32. So you no longer have the brackets. What you need to do is just to make sure that the bases are the same. So you might need to rewrite this 32 in a form of something to the power of something. Based on my experience, because this 2 has to be the same as the other one on the other side, then you might find yourself having to try figure out what is 2 to the exponent of something that will give you 32. If you say 2 to the exponent, let's start with 4, gives you 16. Definitely it's going to be 5. Yes. So that means 2 to the exponent of 5, it is the one that gives you a 32. So now that the bases are the same, they fall away. What do? You equate their exponents. So that means you end up having that dividing with that. Why? Because it has to cancel. Whatever that you do on the left, you do on the right. So you had to divide by that 2 so that it cancels completely. Then now you see you have letter equals a number. If you punch it on your calculator and it gives you a decimal, just leave it as a fraction. Don't need to write it as a decimal. So that should be the end of it. I'm just hoping that as I work out these problems, I do not make some mistakes. Just keep an eye on that. But definitely, if you follow the math procedure, you will never go wrong. So just have to make sure to be extra attentive. Likely this one I can already see that it is correct. Okay, so now problem number 2, let's say you are given 3 in the brackets. Let's say it is 3 to the exponent of x, and then again we square that. Maybe let's equate it to 2, 4, 3. First thing first, I think we might as well just remove that 3. How do you remove it? You divide both sides by exactly that so that it cancels. That's how it disappears. Then you remain with your 3 to the exponent of x squared equals, what is that when you punch it on your calculator? You'll say 243 divided by 3 gives you 81. Then Now it's like you're doing example number 1 where you multiply the exponents, and then you have 3 to the exponent of 2x, which is supposed to be equals to, then 81, it will definitely have to be 3 to the exponent of something. Let's see, 3 to the exponent of, maybe 4. Yes, 3 to the exponent of 4, it is the one that gives you 81. So it therefore means you have 2x, you equate it to 4. Why? Because the bases are the same, they fall away. So that is the main aim, to make sure that the bases are the same so that they fall away, and then you divide by 2 so that that cancels completely with that into that, it's equals to 2, and that is the end of that one. And let's see, maybe I can squeeze in. Okay, let's do problem number 3, where you are having 5 to the exponent of x, where you minus 1, close that, and then this is being equated to 125. Again, you are having the brackets. How do you work out this one, where it is not just a letter, but it's a letter minus a number? You will do that by that by that, meaning you multiply each term. So you have 2 multiplying that x, it becomes 2x. You have that one multiplying that 2, it becomes negative 2. Yes, this should be equal. So I think 125, let's straight away work it out. 125, it should definitely be 5 to the exponent of something, so that these bases are the same. What will it be? Let's say 5 to the exponent of 3. Yes, so that means it is 5 to the exponent of 3. Now the bases are the same. What do? You equate their exponents. So now we equate their exponents, and then you start solving. It's like now you are having your linear equation, where now 2 goes to the other side, it changes a sign, it becomes a plus, and then you are having 5 there. You need to remove that 2 so that it cancels completely. Remember, main aim is for you to finally say a letter equals a number, and that should be the end of it. And quickly just double check that by that by that. Yes, that to the that. And then you've got the exponents being equated, and then you solve. That goes to the other side, becomes 5, and you divide by that, so it cancels, and that should be the end of it. Then now let's look at example number 4. Of course, I'm moving at a faster pace because this is connected to the lesson that we did on the laws of exponents and exponential expressions. So the example that I've done in the beginning, it is connected to these ones that I have done. So trust me when I say you just need to do the first few, and then with the others you need to redo them as many times as you can, so that it becomes part of your DNA, where you just look at it and you know what you need to do. Then it's just a matter of you writing. So now let's say we have this being 4 into 2 to the exponent of x, and then raised to 3. Again, let's say 128. Okay, so if you have this, it looks like it is that one where we need to just remove that 4. Then you divide both sides by that so that it cancels, and then straight away we can multiply that by that. Then we have removed the 4 and we have removed the brackets, and then it ends up being that, which should be equal. Okay, what is 128 divided by 4? Definitely that is 32. So next step, I think you now have an idea of what needs to be done. It will have to be 2 to the exponent of something. Let's try 4. 2 to the exponent of 4. Nope. Oh yes, it's 5. We've done it before. To the exponent of 5. So the bases are the same, they fall away, and then you remain with 3 to the exponent of 5. You now equate the exponents. Now you need to remove that 3, so that you will see letter x is equals to 5 over 3, and that is the end of it. Not sure if there's a space there to squeeze in another problem, but it's fine. I'll just go back to number 1, and then I will do example number. Which example number is this? Okay, Looks like it's example number 5. Okay, we have 2 into 4 to the exponent of x. This should be equated to 32. Then again, let's remove that 2. How do you remove it? Divide by 2. Then you have 4 to the exponent of x. What is that into that? Definitely it is 16. Then you have your 4 to the exponent of x. I think 16, definitely it is the same as 4 squared. Then you have your x being equated to that 2, and that's how you simply and easily work it out. So now let's jump on to problem number 6. Let's see how it looks like. For problem number 6, we have 3 to the exponent of 2, where we minus x, and this, it is equated to an interesting one. It is equated to 1 over 9. Okay, so in this case, remember you are dealing with the exponent. So anything which is a fraction, you try by all means to convert it from being a fraction to being an exponent. So 1 over 9 is where we are going to start. And what we are going to do there, you see there 9 can be written as 3 squared. So I haven't changed anything. I've just written it in its exponential form. So now what I don't want, it is the fraction. So how you remove the fraction? Obviously, this is how it works. Your denominator, you will write it as the numerator or in the position of the numerator, but with its negative exponent or with its opposite sign. So you will have that one, which is that one there, multiplying. Now you just rewrite this in its exponential form, but in the position of the numerator. So that's what happens there. So when I say you rewrite it with its opposite sign, it means if it was a 3 to the exponent of negative 2, you were going to still write it in that position, but with its opposite sign, meaning it was going to be a position. So in short, you just rewrite it there, and then you just change its sign from negative to positive or from positive to negative. It depends on what it was originally. So you see now, this times that, definitely anything that is being multiplied by 1, it doesn't change. So you now have your 3 to the exponent of that being equated to 3 to the exponent of that. Bases now are the same. So you end up having your 2 minus x being equals to negative 2. So you can take that 2 to the other side if you want to take a long drive. And then you end up having negative x equals to negative 4. Just be aware that you have invisible 1 there that you will need to remove. That is why you divide both sides by that negative 1, where you will say your letter is equals to, that cancels, it goes 4 times into 4. That is 1. That goes 4 times into 4. So that is the end of it. Not that it's a lengthy calculation. I just had to make sure that I do not skip any steps so that you've got it on record. Okay, so now let us quickly check. Problem number 7. For problem number 7, you've got 5, and then let's say 5 to the exponent of x, that we plus it by 1, and this is being equated to 625. Okay, first step, I want to remove that 5. That's why I'll divide both sides by that 5 so that it cancels, and then I remain with 5 to the exponent of that being equals to 625 divided by 5. It is 125, and I think I've done 125 before, where I just have to now rewrite that as it is and say 5. Why 5? So that the bases are the same. I think it's 5 to the 3. I think it's 5 to the 3. Yes, that gives you 125. And then you are having x plus 1, which is being equated to 3, because the bases are the same, they fall away. So you have your x now being equals to 3, definitely minus 1, and then your x will therefore be equals to 2, and that is the end of it. Hope I've done it correctly. So let's now look at example number 8. I think, yes, example number 8. Let's see. Okay, let's say you are given 7 to the exponent of x squared, and this is equals to 1 over 49. Okay, it shouldn't be complicated because I know that 2 has to multiply that x, then I have 7 to the exponent of 2x, which should be equals to 1 over, definitely 49 is 7 squared, that I know. So again, I will still do the same way. I have to rewrite this as that invisible 1 multiplying 7 to the exponent of that, just like I did with which example? I think it was example number 6. So the bases now, they should be the same, because this one multiplying by that, it doesn't change that, it just remains as 7 to the negative 2. Now the bases fall away. You can equate the exponents. Then now let's remove that 2 or detach it, so that we end up saying letter equals a number, and that is the end of it. That is how you know that you've dealt decisively with an equation. You must be in a position where you have a letter being equals to a number. Okay, let's jump on to maybe example number 9, where we have 4 to the exponent of, let's say, 2x minus 1. We equate this to 1 over 4. Again, it shouldn't be complicated. Just like I've done there, I will therefore end up having 4 to the exponent of negative 1, because remember, you have invisible 1 as your exponent there, and we know that 1 doesn't change anything. So that is why now I will end up having the same basis. Then all that I have to do, it is to just equate their exponents. Then I end up having 2x, which should be equal, you take that one to the other side. What does it become? Take it to the other side, it looks like it will be negative 1, that you plus it with 1. Then you have 2x, which should be equals, I think that should be 0. Then you need to divide both sides. You have your x being equals to 0. Yes, 0 divided by anything, I think it is 0. 0 divided by that, yes, definitely that is a 0. Let's see. Okay, let me look for a space where I can squeeze in the next problem. Not sure if I've got enough space there. Okay, problem number 10. I think I will do 2 more after number 10. Let's say we have, okay, 3. Then let's say that, and then 1 over 3. This is equated to 1 over 3. Again, I will need to remove that. So that means I will need to divide both sides by that 3, so that I will just end up having that 9 to the that being equals to, then what is 1 over 3 where you divide it by that 3? Okay, it gives 1 over 9. It gives 1 over 9. Already looks like I know what the answer would look like. Definitely it will be 9 to the exponent of x minus 3, which should be equals to 9 to the exponent of negative 1. The bases now are the same. What you do, you equate their exponents, and then you end up having your x being equals, you take that to the other side, it will be positive 3, so it's like positive 3 minus 1, which will therefore be equals to 2, and that should be the end of it. Which other example can I squeeze in? Let's see. I'll just create some space there. Okay, then it's fine. Let's do, I think it's example number 11, where you are having 2, which is inside the brackets, to the exponent of x plus 2, and then that is being raised to 2, and then this is equated to 256. Okay, again, that by that, that by that. So you end up having 2 to the exponent of 2x that you plus it by 4, which should be equal. What is 256? 256, will it not be 2, let's say, to the exponent of, what about 8? 2 to the exponent of 8, 256, yes. 2 to the exponent of 8, it is that. I just had to guess there, a bigger exponent. So you can just guess and say 2 to the exponent of maybe 5. If it doesn't work, you keep on adding until you get to that one. There's another way in which you can easily punch it on a calculator and then it gives you s2 to the exponent of 8. I will show you that at a later stage. But for now, this is the basic way of doing it. So now the bases are the same. You know very well what happens. They disappear, and then you just equate their exponents. So you end up having 2x, that should be equals to this, you minus 4, and then it becomes 4, and then you divide both sides by 2, and then that into that, it is 2. That should be the end of it. So maybe let me do one more problem. I'll just use that space there in between. So let us say, this being the last example, let's say you are given 6 and then you have 3 to the exponent of x. Let me just close that, and then we equate it to a fraction being 54 over that. Okay, what am I going to do here? I will definitely divide both sides by 6 so that I remove it. So you can see there's a consistent pattern here where things repeat themselves. So already I had 54 over 6. Now on the side I'm just going to divide it by 6. Let's see what it gives me. Wait, did I copy the question correctly? Might need to verify that. Where will I get that problem now? Okay, let me quickly check. Okay, I think I've got an idea. Let me go back to the previous page. Oh yes, 54 over 3. That should be the correct equation, not 54 over 6. So I will just need to erase that and that, and then say 54 over 3. So that means it is the one that I divide by that 6 that is going to cancel on that side. Yes. So when you say 54 then over 3 and you divide it by 6, it gives you 3. So that means you are having 3 to the exponent of x, which is the one being equated to 3, obviously to the invisible 1 over there. So that you end up having the bases being the same and they fall away. Then you've got your x value being equals to 1, and that should be the end of it. I'm hoping that I've done everything correctly. Maybe let me do this so that you can take a screenshot. Otherwise, if they are too small, then just make me aware so that I can share these calculations on the website, and that's where you should be able to access them. So I think on my side I've done all the examples that I wanted to do for now, and then I will just end it here for this